Hello, hello, I am Joe the Science Bro, and this is Science Talk. Now, I know we had a couple of weeks there where we really weren't doing anything for Science Talk, and I do apologize for that, but that is what happens when, one, you get sick with COVID, and two, everybody keeps canceling. So, anyway, I am, as always, very glad that we can do this. I'm very happy that you guys will be joining us. I have a wonderful guest who actually just got conferred his degree, and I know that that's something that you don't normally get to see. You don't get to see that a lot. You don't get to interact with that a lot. So we're going to be able to actually do that today for the first time for a lot of us. Just a couple of housekeeping things as always. If you are enjoying your time here at the channel, please give us a follow. Make sure you join the Discord so that you can keep up on updates. If you feel like it, subscribe. You don't have to, as always, but it does help me, do this and many other things. So, with that all said, I want to take this moment and introduce our wonderful guest, the newly minted Dr. Vignesh Sivaganesh. I did it right.
Yeah. Thanks for having me. This is going to be honestly such an incredible time. I hope we get to talk a lot about everything, right?
Right. So what many of you don't know is before he was Dr. Vignesh, he was just Vig, the student in my lab working on, as many experiments as possible. So before we get into all that, why don't we talk about the basics first? Why did you choose? Number one, I know that you're also in a DO PhD program. So now you've got a PhD, but why did you want to become a DO to begin with?
Right. No, so that's honestly a great question. So this interest in medicine in general, it started back in high school, honestly. So in high school, even prior to my entering high school, I was actually more interested in actually going the computer science route. That was kind of where I wanted to go, right? That kind of work is work that my dad did. It was something that I thought that I would be interested in, and I was. In high school, I actually then ended up taking this honors anatomy and physiology course. And I sort of used that class as an opportunity to sort of figure out whether maybe I would be interested in this whole medicine thing as well, or biology or something of that sort, right? And so in that class, we got really cool this opportunity to dissect like a fetal pig and cats. It was so incredible to see that for the very first time in my life. And that started to get the gears grinding on, maybe I'm interested in this biology medicine thing, right? Like maybe this is what I want to do. I started getting confused.
Yeah.
I was like, oh no, I like this too. But as time went on, you know, I felt that while in that class, I started really deviating more towards this subject than I did with computer science. I was pretty good at it. I was pretty good at coding. I had a knack for it, but there was just something that kept bringing me back to physiology and biology and sort of medicine overall.
Yeah.
Right. And so just being able to sort of peer into these structures in an animal and just looking at how complex and complicated, how complex we like mammals and animals are, right? It's fascinating. And so that really got me into so much so, like I started really getting into this biology thing. So that was sort of like the awakening phase, right? Was high school. I was like, okay, this might be for me. When I applied for my undergraduate studies, I applied in that biology, physiology, that kind of type of major, and went to UC San Diego where I studied physiology and neuroscience. So that was my major that I studied throughout my 4 years in undergrad, and that's when things really took off. In my first few years, so my goal with what I wanted to do with this knowledge in biology was really, my first goal was physician.
Yeah.
So, you know, nobody in my family actually really is a doctor or in medicine, actually. At least all the family that I can think of, right?
Yeah.
None of them. A lot of them are more into like computer science, engineers, stuff like that. But no one's really in medicine. So I was kind of treading water that I wasn't really familiar with, to be honest with you. And, you know, I wanted to see whether that interest was really something that I could pursue. So one thing I did kind of early on was I just tried to get involved in college and as much things as possible. Yeah. You know, at first I did join research because a lot of people did tell me, hey, this is an important component to not only just applications for medical school, but also for your knowledge base as a future clinician. You want to get your feet wet in research. Right. So I joined a lab pretty early on in my undergraduate studies, and this was still with the whole concept of just being a physician in mind.
Yeah.
But when I first joined that lab, one of the coolest things that happened when I joined that was that lab did a lot of cancer research, sort of in vitro or in plate cell culture type stuff. Right. And so one of the first times I joined that lab, I remember my mentor at the time, he just took like a plate, you know, just a casual day in the lab, right? He took a plate, put it under a microscope. He said, hey, take a look at this. And I'm looking, and I'm like, what is this? He's like, yeah, those are our cancer cells. I'm like, these are cells growing in plates? That was amazing, right? That was the first time I've seen that, like, alive in person. And I thought that was the coolest thing, that we can manipulate so many aspects of these cells in vitro and then be able to do something with it and figure something out that's completely new and completely like it sort of contributes to the field in this like novel or new way, right? And I thought that was very fascinating. So while I was always interested in being a physician, now I'm like, oh man, I kind of like the science thing.
You got
here we go.
Research book.
Yeah, I'm like, oh no, here we go. Oh, the science thing is pretty cool. Okay, let me put everything I got in. Like I want to
one
really,
of us.
Yeah,
one of us.
I got bit by the bug, man. And I started going in, you know, balancing my studies and also going into the lab, and I really devoted a lot of time. It was just such a cool experience to and I do want to say one of the important things about that kind of got me interested in science was it's just so important to have a good mentor, you know.
Yeah.
That can be everything sometimes. And
no, you're absolutely right, especially because I can speak to this myself. You know, I'm the first one in my family
Right.
to have ever gone into science.
Right.
I'm one of the only ones in my family that actually got an advanced degree. The only other one who has a degree that's even remotely level to me is my uncle,
Right.
who got a master's in business administration. And, he's a master's of business administration. My aunt works in taxes. My mother was a legal secretary.
Right.
My father was a history teacher.
Yeah.
And my brother is a Catholic priest. Like, quite literally, we're all over the board.
Yeah.
And
then you're like, I'm science guy.
it's like science, just understanding the natural world is what grabbed me.
Yeah.
And I understand completely what you're talking about, because a lot of us, we tend to have, a lot of scientists tend to be family deals. Like you have one parent that's like a chemist, another parent that's a biochemist, or you have someone who's a pharmacist, or somebody who's a psychologist. Like, there's some knowledge of what's going on. I remember one day my dad looked at me, and it was when I was in graduate school, and he went, I have no idea what it is that you're going through. You need a mentor.
Yeah.
And I was like, well, yeah, I know. He's like, no. You need someone to be like that Godfather type person who is literally making sure that you're not being stupid.
Yeah, absolutely. Yeah.
It's the problem is that a lot of scientific graduate school is it's in the dark.
Yeah, it is.
It's very much a dark process.
The process to even get into that and what you need to be competitive, all that was completely foreign to me.
Oh, absolutely.
It was so difficult to navigate that, being sort of the only one in my family that's gone through this path.
Yeah.
And especially because, my family and I, and me too, we were all born in India. I moved here when I was very young. Yeah.
You're kidding. No.
Yeah. And, so the U.S. school system too, compounding the issues that we have with the transparency of getting into graduate school. Then you have we got to navigate the U.S. school system now because
it's a completely different world.
You're the oldest child. Have fun experimenting.
Right, you're the one who figures it out for everybody else.
You figure it out. And my parents were great at helping, of course, but they can only go so far. And at some point, then I got to kind of fend for myself out here and figure things out.
Yeah, exactly.
And so having that mentor is so key, to getting into this. Like, I definitely felt I did have this intrinsic passion that just needed to be unleashed. Yeah. But I felt that having these mentors in my undergraduate career really helped that come to life.
Wow.
Right. And so, that's that goal of being a physician was always there. Well, I guess mainly since high school, going into my undergrad. And that, again, going back to those classes in high school, what really made me want to do that is I really thought I could take this kind of knowledge and apply it in a situation where I could truly help people on a day-to-day basis, right? Like, I did have this desire to be able to help people in perhaps sometimes their darkest moments, right? And I felt that with this type of knowledge, something that I am interested in, I can utilize it to that, for that goal. But this whole science thing really did come from the fact that I just got exposed to it. I got exposed to good methodology, good ways of how to think about and approach things the right way, sort of. And that just really, as you mentioned before, it's a bug. Understanding the natural,
it's a bug that bites you.
The natural world and how things work, and being able to discover something was just, that really kicked in college, to be honest with you.
Yeah, it's the kid that's taking apart the toaster when they're a kid.
Yeah.
It's the kid that's building with erector sets and connects and Legos, Lincoln Logs, all this stuff that we consider these weird traits. Yeah. They're just keeping busy. No, they're trying to figure something out. Right. They're trying to, that kid that's building with the Lincoln Logs, that angle that they're going at, they're trying to figure out how far out they can go without support.
Yes. Exactly.
It's very much trial and error.
Yeah.
Especially when you're a kid, and for some of us that trial and error is a fun process. Yeah. For some of us it's a probably a mundane task.
Yeah. Of course.
And one of the things that I told Vig when he first joined the lab, I was like, listen, because he was like trying to like do all this stuff
So much.
all at
Oh my
once, and I'm like,
goodness.
whoa. Some days you're going to be busy,
Yeah.
but other
Absolutely.
days you're going to be throwing pencils at the ceiling.
Yeah.
So it's like, I think I remember the first week that you were in, I was like, that Friday, I was like, go home.
Yeah.
Relax.
Yeah.
You're not going to get many of these days.
Yeah.
And I think I told you to take off like probably more days than you thought you were going to.
Yeah.
In your entire time as a PhD student, you
yeah,
probably
yeah.
took more days. I don't want to say like you didn't get work done,
No,
but it was
no.
more like when you didn't need to be
Yeah.
here.
Absolutely.
I was like, dude, just go
Just
home.
go home. That
Because
break
there's
is important.
there's a certain, you can get way too wound up
Yeah.
in this process.
Yeah.
And I know that from experience, both in graduate school and in my own times attempting to get a PhD. You know, I've seen some really good programs that what they do is they kind of make it so that you get a good environment.
Yeah.
And then there are other programs that seem to be built just for putting as much pressure and pain on you as humanly possible.
Yeah. Yeah.
And that's like one of the worst things.
Yeah.
And I never wanted that.
Right.
And
right.
you know, you and I have had the talk before.
Yeah.
One of the major reasons why I'm like, I don't want to go back to that is because why would you want to?
Mm-hmm.
You know, it's like, oh, go for the third time. You know, it'll be fine. It's like, no thanks, I'm good.
Yeah. Yeah.
You know,
Exactly.
it's like, no thanks. I get to do research every single
Yeah,
day. I get to
yeah.
research topics. I get to talk to my bosses about science. I get to do this.
Yeah.
You know, there's things that I get to do that, you know, I don't get. I would probably be able to do as a PhD,
Right.
but it's definitely a different world.
Yeah. It is.
When you finally get those 3 letters at the end of your name,
Yeah.
it is a completely different world.
Yeah.
So
Yeah.
let me ask you, how does
Yeah.
it feel now having a PhD?
Oh man, it's sort of surreal at this moment. You know, it's been what is it, like a little over a week probably,
Yeah.
right? That I've been able to.
It's like a week and a half.
Week
now
and a
at this
half.
point.
Week and a half. It's a very interesting time. You know, because as you brought up before, I think for a lot of researchers at this state, it's sort of typical to what's the next phase of my postdoc? Am I going into industry? For me, I'm like, off I go back to medical school.
Yeah, you're going right
it's
into rotations.
Yeah, and I
aren't
have
you?
all this prep work for that, and it's so it's sort of like a different world than perhaps what most PhDs coming out of that are used to, right? So it feels right now it's nice to mainly just take a little time off and kind of wrap things up here and wrap up a little bit of the work that's going on.
Yeah.
But honestly, it's also just been sort of getting used to it.
Yeah. No, it's a paradigm shift.
It is. There's something that does come with the title,
Yeah.
right? And with that, I think there's of course, the expectation of expertise, which is warranted. And with that, I think that takes a little getting used to.
Yeah.
Yeah, it just feels good to get through it because it's of course a very difficult process. The entire thing.
One professor of mine likened it to a mantle of responsibility that comes upon you. Suddenly now it's like, oh, I am now responsible for things. It's not like what I have where it's like I can get a paper published where I'm on there and the likelihood of somebody asking me a question about that is almost nil. You, on the other hand, you're going to have to remember every single paper that you are going to be attached to. Because at any moment, someone's going to be like, hey, there was this obscure paper that you had your name on, probably because you did like 2 things for it, and those 2 things merged into a figure, and now you have to answer a question about the whole project.
About the whole project,
like, I don't even know what that paper is about.
No, that's true. That's so true. And I feel like that sort of responsibility, it's definitely going to come with a lot more experience.
Yeah.
Right. I'm like a baby doctor right now, I guess. I'm just fresh out. So now with that comes all the years of experience that will inevitably come under my belt.
Right.
And I'm really looking forward to that, to be honest with you.
So, we've had many different doctors, PhDs, pharmacists.
Yeah.
Because Dr. Goldstein was a doctor of pharmacy, which is a PharmD.
Yeah.
We've had Dr. Balin, who's a traditional PhD, Dr. Bravo Nueva, who's also a traditional PhD. Same with Dr. Chen, but Dr. Chen was an MD PhD because she was in China and got her MD in China, and she doesn't, maintain her license, I guess, in here. Why did you want to become a DO PhD?
Yeah, so...
What's the difference from, let's say, like a clinician to like a clinical researcher?
Yes, so this sort of does go back a little bit to that story in undergrad, right? So when I got into the undergrad institution, I thought, okay, so I'm good to go on physician, and then I did the science thing, and I'm like, oh gosh, here we go. Science is cool too. I did test my waters in both aspects too. So I test the waters with the scientist thing by joining labs.
Yep.
My first lab was a cancer lab. The second one, we did like gut microbiome studies in mice. It was a really cool opportunity for me to gain a little bit of experience in the bioinformatics world as well, just processing all that. Python, man.
Hey. Now you're getting into my world.
Python. Whew. Yep. I used a lot of that in that lab. And then with the physician part of it in undergrad, I tested those waters I was actually an EMT for 3 years during my time. I thought it was a good way to get clinical experience. I saw so many different cases during that time, so many different patients. And
I didn't know you were an EMT.
Yeah. It was a fun. It was a
you really like dipped your toes.
Oh,
Not just dipped your toes. You like dipped in the whole leg.
Oh
man.
yeah, I was so busy during my college time. Man. it was good to keep busy though.
Yeah.
And I liked it too. I enjoyed talking to people. I enjoyed being in those situations and doing what I could to help, my part to help. And so now that I knew that I liked both, application season's around the corner.
Yeah.
So here we go, right? And, interestingly, especially I think it's more prevalent now, but back, when was I applying? Like 2017-ish.
Yeah.
So just even 5-6 years ago. Me too, my biggest thing was I knew that physicians were MDs.
Yeah.
I didn't even know what a DO was.
Yeah, most people
really
don't.
Didn't.
Yeah.
And I just never really, looking back, I'm like, yeah, I did see people with DO, but I didn't really make much of it. I was like, this is my physician. Cool.
Right.
But I started looking into this DO route as well because it was introduced to me. I was able to look into it in my later undergrad years, my last few years, and I'm thinking, what is a DO? What is this, right? And you go into it, and you're like, okay, they're U.S. physicians, just the same as MDs. In my experience, in my first years of medical school, I can definitely tell you we learn everything an MD learns, but we also get the osteopathic component of osteopathic manipulative medicine, which is sort of a field of manual manipulation that gets incorporated into our training. I like to say it's somewhat because people know this, it's somewhat similar to physical therapy and chiropractic work.
Yeah.
But it's also different.
I've always likened it, since I'm a beneficiary of OMT.
Yeah.
I've always likened it to kind of like a targeted form of massage. Almost, where you're literally manipulating not just the joint but also the musculature. You're taking into account a lot of the medical aspects of what is going on.
And you get the added benefit of that practitioner being a licensed clinician who has gone through medical school and knows the traditional, those medicines and things that we get taught.
What, you're telling me that you don't want to dance naked under the full moon to try and cure someone's hemorrhoid?
Maybe back when whenever that was happening.
See, I can make these jokes while I'm just going to call you Vig. I'm never going to call you Dr. Vig. While Vig is here, because we got to know each other very well over that. It's been 9 months basically.
It has.
We're almost coming up on a full year, so actually it's more like 11 months.
Yeah,
at
in
this point.
our
Yeah.
in a lab enclosed in those walls
Yep.
for 11 months.
Yep, for like 11 months. It's
Yeah.
basically 10 months, but now we're coming up on month 11.
Yeah.
And there's just so much. So we actually have one of our first questions for you. There's
awesome.
a component that you're going to be able to answer for this,
Yes.
but there's a component that I'm definitely going to be able to answer.
Oh, sure.
So since you're a baby doctor,
Yes.
how much sort of rank is there to different doctors? So for you as a doctor from the DO side,
Yes.
how do you see that?
Yeah, so if we're talking about the stages of it, right?
Mm-hmm.
So on the clinical world, the very first thing is, so what I'm doing now to attest to this is the program structure of this dual degree program was I completed my first 2 years of medical school.
Mm-hmm.
I went into the PhD, finished that in about 3 years. Obtained the PhD, and now I'm going back to finish my clinical years of medical school.
Mm-hmm.
So in those year 3 and year 4, to be honest with you, in the rankings of the clinical world, you are bottom of the totem pole, right?
Yeah.
You are there to learn. You are there to absorb information and to learn from your patients, but to also learn from not only the resident doctors, but the attending physician as well.
Mm-hmm.
The next phase of this in the clinical world would be a resident physician. So, of course, first-year residents are sort of lower on that scale than the second and third-year residents who have more of a say in things.
Yeah.
Then after that, you can either become an attending or become a fellow if you want to subspecialize in something.
Yeah.
So fellow doctors are a step above. And then finally, you are at the level of attending where that's the point where you have the most expertise.
Yeah.
People will pretty much come to you for anything and everything when it comes to something that they need, like a question that they have in regards to a patient.
So is an attending similar to a primary care physician with their own practice?
Yes. So a primary care physician with their own practice is an attending.
Okay.
You have to have gone through that training and get your board certification.
Yeah.
And get that level of attendingship in order to then have let's say your own practice.
Mm-hmm.
And so that's sort of like the hierarchy of that. So right now, in the medical world, I will be entering in as a student, even though I have the PhD, that doctorate, that is in the research perspective. Like
Yeah.
it's a doctorate of cell molecular biology, and my work was a lot in cancer, so I have a lot of expertise in that. But when it comes to the clinical world, I'll be entering back in as a third-year medical student, just ready to learn, looking forward to the experience.
Yeah, in the scientific world, meaning the research world, there are kind of some stages.
Yeah.
You tend to have those guys that get their PhD,
Yeah.
and then all they want to do is teach. Those are
Right,
just
so you don't
those
even
are just
do a postdoc.
those
Huh?
are well, they do postdocs
Okay.
because you have to have some expertise in your field. Very rarely is someone going to be able to get like a full adjunct
I see.
or associate
Without having
professorship
that.
without having
Okay.
that. That's a very rare situation. You'd have to be like really up on your game, or you would have had to have published something that
Right.
basically said, "Hey, I am the man, and you should understand that." So, I mean, there's no like outward stripe, or there's no like I've published 17 papers. I mean, you can look that stuff up, but that's kind of like nitpicky, and a lot of other researchers, whether they're technicians or they're senior researchers or they're professors, they kind of look at you like, and
Right.
a lot of people like to say you're only as good as your last game, or
Right.
you're only as good as your last whatever. For science, you are almost only as good as your last paper and how well your last paper stands, but also you're building a body of work. So if you only have 3 papers, and they're weak,
Right.
you're looked at as a weak scientist. But if you have 3 papers and they are rock solid, and it's been cited like multiple times, you're considered, an expert in the field.
Right.
So you have, once you get your PhD, you go into a postdoctorate fellowship, which is basically an extension of the journeymanship that you've had as a PhD student. It's almost like more of a true journeymanship. You're no longer an apprentice, which is what I would consider a regular graduate student, or a journeyman, which is what I would consider someone into a PhD or someone who's getting a
Right.
master's. you're more of a mentee at that point.
Yeah.
You're being mentored to actually be able to take on something to your fullest extent.
Mm-hmm.
In a way, you're almost a partner in the work.
Mm-hmm.
And then once you get your postdoc, you're a full doctor. You're a full doctor technically from the moment that you graduate.
Yeah.
But a lot of people don't really. They're like
it's sort of like a postdoc is almost the equivalent of a residency, isn't it?
Yeah.
And then
in a
after
way.
that, you're kind of like the equivalent of an attending.
Yeah. You are absolutely expected almost like it's you're evaluated on how productive you are inside your postdoc.
Right.
And it's almost a requirement for you to have, let's say, published 3 papers in your postdoc period.
Mm-hmm.
And that's considered a relatively normal production. Postdoctorate period can be anywhere from like 4 years to 6 years.
Right.
And I've seen some go as short as 2 years.
Okay.
So postdoctorate fellowships can be whatever you make of them.
Yeah.
It really depends on when the money dries up, to be completely honest.
Right.
There are some guys that sit on postdoctorate fellowships for ages, just because they just don't want the responsibility, and also it's kind of difficult to get the research done sometimes. I know some guys that what they did was protein purification. So they did secondary structure prediction. And what you do is it's a thing called X-ray crystallography, where what you're doing is you are dehydrating a protein down to a crystalline form, and you get this crystal. And there are some guys that they don't need to defend. It's quite literally, there's the crystal, I can do it, suck it, kind of thing. They do have to answer questions, specifics, aspects. How did you come about this? Things like that. But an X-ray crystallographer today is worth his weight, literally, in gold, because we still haven't gotten secondary structures for even half of the known proteins that are out there.
Right.
And we're seeing different conformers for the proteins.
Yeah.
So having just done the evolution into a PhD, how much trouble was it having to officially add doctor to your name?
Oh, so there's really no official process for that. Yeah, I think, you just, now when you fill things out, you click doctor instead. And that's sort of it.
That's pretty much it.
And I think the most official part that gives you that right is, your diploma, that's sort of the evidence and proof that, you have the title of doctor.
So are you going to commencement this year? And that's when they're going to officially confer your... So I should explain this because this is important. Yeah. When you graduate from graduate school, you're not graduating, you're being conferred your credit. Your base, it's a... What's the best way to describe this? You are being recognized as your degree level. Yes. It's called a conferment rather than a confirmation or a graduation, because you already graduated. That's what baccalaureate is. You graduated in a baccalaureate.
The BS degree. Right.
Yes, a BS degree.
Yeah.
Trust me, we all made that joke when I was an undergrad. I went to a community college, so that's an associated and applied sciences. So, we were all going, that's an ass degree. So, at what point do they give you an underground volcanic layer? I'm still waiting on mine.
Yeah, same.
I haven't been receiving my catalog recently, so, I last time I checked, the rent was pretty high. It's a little hot these days.
Once you've gotten through the master's or PhD, we should just be given that.
Yeah, basically. I mean, that's one of the things. Some countries, and this is another thing, is that PhD kind of varies from country to country to country. Mm-hmm. Some PhDs are not, in science, are not called PhD. They're not called philosophical doctorate. They're actually called doctors of science, which is a DS with a lowercase c.
Right.
And then there's... what is it? It's...
There's DSC.
Yeah, there's DSC, and then there's another one that's out there.
There's a couple others. I can't think of it off the top of my head either.
But I think it's Finland. I believe it's Finland. If you get a PhD there, when you're conferred, you are actually knighted in a way, and you're given a top hat and a sword.
Oh my god! Because you have to kneel and they do the thing.
Yeah.
Oh, that.
Yeah,
That'd be
no,
awesome.
absolutely.
I would love that.
Yeah, no, I'm right there with you, man.
Dude, I think one of my friends too, before the defense, they were like, "So, do you get knighted or something?" It's like, no. I wish. But no.
The funny thing is that scientific advancement in terms of the educational sense is very much. It's weird because it's a very secretive process. So you have. And you experienced this, so you'll be able to tell us a lot more about that. But you have a committee,
Yes.
and your job is basically to make them happy. If they say jump, you don't just pull out a trampoline. You pull out a trampoline, and you have 4 others waiting just in case they want you to keep going. And you've broken that one. You're talking about you're at their beck and call almost daily.
Right.
You know what it's like because you probably had 1 or 2 of your committee members texting you, emailing you, giving you a phone call.
Yeah.
I'm surprised you didn't see smoke signals or Morse code coming towards you. But there are other members of your committee that probably never interacted with you until you were discussing specific things.
Yeah. So fortunately, this is my case. Fortunately, my committee, they were all really great. To be honest with you. I had the benefit of so they didn't ever come at me too hard, which is great. I didn't have anybody.
Well, it didn't seem like that. That's the thing. It didn't seem like that. You were just well prepared.
Yeah, it could be that. But I always thought that at the end of the day, the feedback that they provide from that sort of outside perspective is very valuable.
It's constructive.
It's very constructive.
Yeah.
At first you may get some feedback and sitting there like, oh my gosh, how am I supposed to do this, right?
Yeah.
And that's difficult to kind of navigate. But in all honesty, otherwise, I felt I have heard stories of committees being
evil.
Not great.
Yeah.
But that was not my situation at all. So I'm very grateful for that, to be honest with you.
I mean,
because it is a very important part of your PhD.
Exactly.
And I was fortunate to have honestly incredible committee members who were just. I felt that.
Yeah.
Everything they did, they really were just looking out for me and wanted my project to be the best it could.
That's the object of the game.
So
once
that is the intention.
Yeah,
right?
that's the intention.
Yeah.
That's one of the biggest things that my biggest mentor he always discussed with me. It's like the object of the game is to get you to pass.
Yeah.
And if you don't pass, it kind of reflects negatively not on you, but on your committee.
Right.
How much do they actively try to poke holes in your thesis, or does that all change based on who you get?
No, they all do.
Yeah, that's the object of the game.
And I think that's very intentional. And I actually, when I look back at it, I think that was a very critical part of the entire process. Like, for them, right up even till the very end, even after the defense, they're asking questions that sort of try to poke holes into your thesis. And that's sort of why it's called a defense. You're defending the work that you did. But even prior to that, in our committee meetings, I would present data, and their job was to make sure that it was rock solid.
Yeah.
And so they would ask a variety of questions that would attempt to poke holes. And I think, as Joe mentioned, I was fortunately, most of the time, I was pretty prepared.
Yeah.
And so I had my stuff together. I'd have alternatives if they were just not okay with what I was presenting. So you always have to come ready to pretty much.
You got to hit every pitch.
You got to fight for your stuff, and if you can't, you got to have alternatives to your work so that you can explore other avenues and figure out ways to make your work stronger. So no, they definitely did. That's kind of their main thing is they want to make sure that your work is solid so that when you get to the point of finally obtaining your PhD, it just doesn't fall apart, right? Everything's good to go.
It has to. So one of the things that comes with this, and again, I'm sorry that I'm doing a lot of the talking to this, but it's there's two sides to this, and having now been on this side in a different capacity to how I was when I was an undergraduate. When I was an undergraduate, it was a lot of, he's got to do this and he's got to do this. Now it's I'm sitting there and I'm like, okay, we're at this stage, and in a couple of months he's going to be at that stage, and then in a couple of weeks he'll be at that stage. It's a domino thing, and it's steps. Part of their job is to poke all the holes. Because what it is, the metaphor here is that it's the dike. It's the gigantic. Your body of work is the gigantic dike, And if you can't stand up to fix the holes that are leaking, your work is just going to crumble eventually.
Right.
So, they are almost trying to poke holes into it to take it apart, to make it seem like you are not worth anything at some points.
Yeah, and it's so they poke holes, and the thing even in those meetings is your job is sort of to defend that part and to be and to come up with an argument as to why they may not be correct in their line of thinking, right?
Yeah.
So that's sometimes it goes that way. Other times they poke the hole.
Yeah.
They just poke it and they kind of get it, and you're like, okay, no, I see what you're saying. You're right. And I got to figure out some way to navigate this.
I've seen a couple of PhDs, and there is a question coming up, but this kind of leads us to it. I've seen a couple of PhD students that they were agonizing over one detail, just one detail of the entire thing, and then they get to their committee meeting, their official committee meeting, and you have several of these committee meetings throughout the process, so it's not like you have one committee meeting and they're kicking the crap out of you. No. They're with you the whole process. And when you sign up to be a committee member, you are pledging that you're going to be there and be a mentor to that student at any time. Yes. It doesn't matter if you're the main contact person, the advisor for the student, or if you're just a committee member, you're expected to kind of be there the whole way of the game. Yeah. So I remember that he was prepping this whole time, and then one of his committee members was just like, yeah, here's this random detail that you didn't consider. What about this? And he fell apart.
Yeah.
So have you ever had those moments where you're just like, I'm back to square one now?
So fortunately, no, I didn't have the square one moment. I did have moments where, I had to go back and maybe correct a couple of things. But fortunately, it was never to the point where, oh my gosh, it's all gone, And I think, again, part of that is like going back to what I was saying before is it's just that was a very fortunate situation for me where I think I in my part I picked the right members that I thought would do everything they could to just like critique my work in an appropriate manner, but like get me to the finish line.
Yeah.
Because they all wanted to be there for me to see me succeed. And I did feel that. So that's why I felt very fortunate to have, honestly, a set of incredible committee members that were just there to support and lift me up and poke holes, but do it in a way that was constructive. You know? And there were times I had to struggle with the comments that they made and kind of go back, and especially my thesis writing, and sit there and kind of bang my head against the wall and like, how can I convey this better? Or, is there another way I can do this? But all of that, I think, all of that feedback really just made everything
it helps
a
you
lot
grow
better. And it makes you grow as a scientist because, we've been in lab countless times when you're talking about some of your work and sort of like, what are the next steps and what do I have to do? And that sort of banging your head against the wall is a part of science.
Yes.
And so to get that early on in your training during your PhD from your committee members who are very especially the ones that I had were very knowledgeable in the general field of my research,
right?
My study. And so while they didn't do exactly what I did, right? Yeah. They had that knowledge of the techniques and the overall science that was involved. So for them to also look at this sort of from an external lens, I thought was very beneficial, because them poking holes or asking questions, you get the opportunity to just critically think your way through everything and try to think of better ways to communicate what you're communicating, or to just go back and say, okay, what can I do to make this better?
Yeah.
And so fortunately, no zero, from the very beginning. But they it was definitely challenging, but very rewarding.
Yeah, these days, I don't want to say it's a lot easier to get a PhD, because that's not technically true. Yeah. But there are certain things that have to happen these days in order for you to get to that final point. Like, in order for you to defend, you have to have your research prospectus okayed, which is a vote amongst your committee.
It is.
And it has to be unanimous. You have a oral comprehensive, you have a written comprehensive, and we'll get into those in a little bit. Both of those result in a vote, and again, they need to be unanimous. And then you have to have a vote just so that you can start writing. And then you have a vote to approve your thesis for public review. And then you have a vote so that you can then present your dissertation. So it reflects more on the committee. If you don't pass, it makes them look stupid than you if you don't pass, because it's like, you guys okayed this? And I've seen a couple of times where I've seen a student flounder, up there, and it's like, oh, he is sweating. And all you want to do, unfortunately, for those poor students is you want to get them off the stage as quickly as possible, but you can't. They're on the hot seat, and there's no one who can come to save you when you're up there. The only person that can save you when you're up there is you,
Yeah, that's true.
So is a dissertation usually all new science that you're breaking ground on, or is it more compiling stuff that already exists?
So it is new science. I wouldn't say it's necessarily always have to be groundbreaking, but it does have to add something to the literature that currently doesn't exist, right? Now, to what capacity, like I said before, I don't think it has to be completely brand new and groundbreaking. It can build upon the body of work that exists, but the majority of a dissertation, that data does have to come from you. You have to be the one to do those experiments. Of course, you can get a little help with that, but like those experiments are your lab's experiments that you conducted during your PhD that get put into that dissertation.
You're expected to do the lion's share of the work, but it's not uncommon for people to have some assistants getting repeats in. Because again, there is a significant level of work that you have to go through in the writing process, and a lot of times, those last few data points are being worked on while somebody is writing up their dissertation. So, I agree with you that it doesn't have to be groundbreaking. Sometimes, because science is baby steps, sometimes you're grabbing like three little bits.
Even an incremental step.
You're grabbing three little incremental steps, and then from there, it's more reliant on your conclusions that you're drawing from your data at that point.
Exactly, and even those incremental steps is so much work just to get that step.
Exactly.
So I think it varies by program, by person, by research prospectus, right? What that research plan is going to be, but there is always some component that is new that has to be brought to the table that adds to the literature.
So now I know this is kind of like still a tender subject for you. Let's talk about your comprehensive.
Sure.
Because I remember you coming in that first time, and oh man, were you low that day? Of course. Tell me about your written comprehensive first.
So the comprehensive
for you, because the comprehensives can be different depending on the institution.
So the process that I went through in particular was I basically had to write sort of a grant, in a form of an NIH grant. And it's supposed to be on something new that's unrelated to what I'm doing in my thesis, right? So have to dig through the literature and come up with some sort of idea that is supported by the literature, but is not something that I'm going to do experimentation on. It's just sort of a thought experiment. So it's a pretty big document, right? You have to compile your rationale, your what supports this rationale, why is this a relevant project, what does it bring to the table, what are some pitfalls that could occur with it, what would you do to fix that.
And I'm guessing you're using some of the data that you're already generating as like the preliminary data to base this theory on.
So no, it's not even related to your work. So
at least for yours.
I used data from like manuscripts and stuff that would back whatever idea I was coming up with.
So you were just coming up with a brand new perspective entirely.
No, it's not related to my work whatsoever. So you can't really use your data, or at least the way this one went. And so that's how that exam went on the written side of things. And the first try of my oral portion of that, right, I came in distraught because I didn't pass the first time, right? And so that happens to a lot of people. It's just one of those things that in that moment was like completely devastating.
Oh my God. Right? So to give you some background, I have maybe seen, so I've been around 5 PhDs. Mm-hmm. One of those 5 had a conditional pass the first time.
Yeah.
Which was, we are passing you,
yeah.
but we want to see more of this particular
yes.
piece, and that's it.
Yes.
In other words, you're coming back, you're talking about this new piece, and then that's it.
Yeah.
But we're basically saying, until that, you're good to go.
Right.
And yeah, I think it's almost a rite of passage to fail that.
It is.
That first try.
It was, the way I thought of it was everybody in the room, including myself, they were like, you can do better.
Yeah.
And I'm like, you're right.
I remember.
You're right. I could.
I remember, I think it was like a Tuesday that you had that oral comprehensive.
I think so.
And then, I told you not to come back on Wednesday because I knew that your head just would not be in the game.
Yeah, it wasn't in the right spot.
And I was like, when you come back on Thursday, we're going to do a postmortem, you and I. We're going to just go, we're basically, and this is kind of where my job in this comes in. And I know Dr. Appel was your advisor, and she probably was doing the exact same thing with you.
Yeah.
I was like, take me through everything from the top.
So, after that first time, I don't know if you recall, but my life was comprehensive.
Yes.
I obsessed about it.
Yep.
And it probably wasn't healthy for me. But
no, it wasn't.
It wasn't. But my headspace was like, I had this burning determination. I'm going to pass the second time. Yep. There is no question. And I came in a lot to do my experiments for my thesis, but there are so many times I'd come in, and what was I thinking about? My comprehensive. And then I'd be like, Joe, I'm writing something on the board. And you're like, here you go. And give me the marker, and then I draw this whole...
I've got this gigantic, I think it's a 50 by 50 whiteboard. And
fill it up.
What was ending up happening was you were having like weeks. I think it was like a 2-month period that you had, and you would have weeks where you were just reading article after article after article. Oh, yeah. And at a certain point, I just looked over. I think you had like moved to the 5th article that day, and I was like, okay.
I think I
did this exact thing. I think I pulled my glasses off, pulled my fingers down on the bridge of my nose, and I was like, here's a dry erase marker. Write out what you're thinking right now, let's go through.
My break was I would eat lunch and read articles, and then he was like, what are you thinking about? Get it out of your head because it's probably all jumbled. So we would go back and forth, write some stuff up. I had other, people I'm very grateful for that were helping me through it as well. And come that second time, I remember walking in after I did it.
You were cool as a cucumber.
You were like, how'd it go? I'm like, I laid it all out there. I remember saying that. I gave it everything I had.
It was me and Sarah were in there. Yeah, and you came in, and we were both just like, how'd you do? And you said you laid every last detail that you could. And that's what I expected.
And I went back into the room. They said I passed, flying colors. It was all good. And that's when I came back into the lab, and Joe and I had a high five and celebration.
Well, the good thing is that it was very much the pressure was let off.
Yeah, and it's a tough learning opportunity, right?
Yeah.
Because when you see the term failure can be so ingrained in your head as a bad thing, but it's not even an actual failure because you're getting the opportunity to improve on the things that you didn't do correct the first time. And so it's not necessarily a failure if you're learning from it and you do everything the next time and then succeed.
Yeah.
Right? Learning from those failures is what leads to success. And so that it's just that term kind of gets to you, but once you get past it, you're like, oh, I can do this. I got this.
Yeah.
It's totally feasible for me to work really hard at this, to correct my deficiencies and come back and attack this thing with everything I got.
Yeah. No, and I mean that's one of the harder parts to get through is the comprehensives. That really is, you'll the phrase gets used way too much, but it really does separate the men from the boys.
It's like a candidacy thing. Like once you complete it, you are now a candidate. And at that point, I mean, things are kind of smooth sailing, you know?
Yeah.
I'm just coming in, doing my work.
And I mean, this is
getting
why
to
a
the
lot
thesis.
of times these comprehensive exams are done in the second year of a 6-year period, is so that you're basically not worrying about this. You're smooth sailing. But I think you had, pardon me, notwithstanding of the pandemic, I think you had, 4 years total?
For the PhD?
For the PhD.
3 years.
3 years.
Plus a pandemic. 3 years, included in that 3 years, my first year was riddled with not being able to go in and all the restrictions that came with.
Yep.
Because it was 2020 to 2021 where the majority of restrictions were in place.
Yep.
That was tough.
I bet.
Okay, I have 3 years, and one of my years is already pretty much shot.
Good on your committee for recognizing that you were basically given the shaft by a situation that was not even in your control whatsoever.
Still got a whole lot done. I got so much done, but that was a tough thing to get through.
That's part of it. We both could sit here and just go back and forth about the entire process because there are certain aspects that are behind the curtain that now that I'm older, don't want to say wiser because that's not necessarily true. I'm older. I'm looking at things from different perspectives now. I see what's going on, and it's like I could sit there and I could tell you, for hours on end, look, you have to go back in there and you have to, hit it harder than you did before. But that's only going to work for so much. That's only going to be worth, what it's printed on, basically. Mm-hmm. And the most I could do for you, at least from my perspective, was basically to just keep your head in the game.
Yeah.
And
absolutely.
That's where my job came in. It was to just keep you going so that you wouldn't stop prematurely simply because you had a bad experience.
The PhD it's a very difficult road, right? I mean, there's so much going on outside of your experimentation. I mean, for starters, you're like a normal human being, right?
There's an attrition rate for mental stability amongst PhD students. And a lot of times when you see this student or that student unfortunately commits suicide or attempts suicide, a lot of times they're in a PhD program or they're in a heavily competitive graduate program.
Right.
And it's because there is just so much mental strain.
Very mentally demanding.
And, what happened to you was kind of odd because we're not going to name specific names of institutions, but your graduate institution that you were supposed to be doing the PhD portion at, it got bought. And not only did it get bought, but they were closing that wing of the institution down, which meant you had
in the future they are.
You had to get out of Dodge because people were like, we're not sure if you're even going to have anything to go to. Mm-hmm. So, that's where Dr. Appelt came in and was like, no, he's coming here.
Yeah.
She came in and she asked me, because I'm also a graduate of that institution. She's like, how bad is it? And I'm like, I'm telling her what the alumni know. And she's like, okay, I'm bringing him in. And the first thing out of my mouth was, that's probably going to be for the best, because quite literally we had no idea what was going to happen next. Mm-hmm. And for a graduate student, that's the worst. That is the worst. Uncertainty is probably the worst thing that you could have had.
Yeah. Uncertainty is rough.
I remember when you came in, it was after they had approved your comp and you were able to go through. I didn't let you just sit, and get back to work. I was like, nope. I want you to get up here. I handed you the marker and I was like, describe your entire thesis to me. I want to know your thesis. Do it. And, so what that does is it makes it so that you can get it out and you can hear it. I told you this, in programming it's called rubber duck debugging. Mm-hmm. It's when you're describing what you're doing to a rubber duck or just to some inanimate object. And the simple fact of you describing it elicits where the locations of a potential bug can be. And I'm not going to lie, I wasn't giving you softballs with the questions. I was absolutely trying to go, well, what about this thing that's completely unrelated could potentially, involve it? I think I brought in like some random IG, which is an immunoglobulin compound that I knew for a fact had absolutely nothing to do with the cancer pathway that you were talking about. But I was like, well, what about it? How is this not effective? That's kind of part of the job. It's like, well, have you considered every single aspect of this?
Yeah.
So,
absolutely.
Tell me about writing your thesis.
Yeah.
Because it literally is writing a book.
It is. So the way I approach thesis writing, to not go absolutely crazy, I really broke it down into the sections that it's usually divided into, right? And so there's a period of time that I said, okay, I'm focusing on the introduction, right? Or now I'm focusing on chapter 5, which is sort of the conclusions of everything, wrapping it up. The good part is the 2 of the chapters, I had a good majority of it written because we were already attempting publication of that anyway.
Yep.
So that was pretty much already in format for thesis, and there's really not much else you have to do outside of it. You just really copy and paste on there since it's already my work. It was the 3rd chapter, the majority of the work that I was doing here at PCOM. That was an entirely new chapter that I came up with, that I recently wrote, outside of those 2 chapters that were already written. So it's a lot. It's just a ton of writing. A lot of rereading. I mean, words start blending together at some point. You're like, I need to step away from my computer. Yeah. It's an extremely large document that's also kind of sometimes difficult to keep track of.
Quite literally, you are writing a book.
It's a huge document.
You're boiling down. So for you, I don't want to say that you kind of had it easy. You actually had it much harder because most PhD programs are 6 to 8 years, which means you have 2 years where you are doing rotations and isolating what lab you're going to be working in. And then you have, you have another 4 to 6 years of just straight research and writing.
Yeah.
And in that period, you can lose so many details. Like, think about how many times I told you about the project that I'm working on with a collaborator, and how many times it's like, wait, weren't you talking about this detail a couple of weeks ago? And it's like, oh my God, oh yeah, I completely forgot about that. That happens so much more the longer you're away from it. So in a way, I don't want to say you had it easier because that's not necessarily true.
Yeah.
You had all of that condensed down. Into a 3-year program, into a 3-year period. So,
Yeah, so that was especially tough, right? Because as you said, it's the combined dual degree makes it so that the PhD portion is 3 years, right? And again, one of those 3 years I navigated COVID.
Yep.
And they didn't water anything down. They were like, yeah, just do this faster. I'm like, okay.
Yeah. No, and that's
they're like, do a 6-year PhD. So I'm like, okay,
do a 6-year PhD in half the time.
A 5-6 year program, whatever it is. And that was incredibly difficult because it's the pace of the research.
Yeah.
Right? That's so difficult to manage on top of there are all the milestones that we talked about to get your prospectus in, the committee meeting. So then all those timelines of, hey, we have our committee meeting coming up is so much closer together. So I'm like, oh my gosh, I need to go into the lab this entire weekend and collect data that I can put into a presentation to then show my committee that I'm on track to graduate in this 3-year time frame.
I mean, for a while there, you were having weekly meetings.
You
were having weekly meetings, and you were also. I know it seems like you were hemming and hawing over all of these little details, but
they're important.
I want to part of this is so that we can get people to understand that this is a very work involved period of time, and it's not easy.
Yeah,
it takes a lot of time and. It requires a lot of dedication, and you had to basically do it in half that time period.
Yeah. So that amount of time, I mean, I was in the lab for many hours, weekends, weekdays. I was in there in the morning. I was leaving at night. I mean, that's just the nature of this program.
I mean, there were times I remember you were sending me a text message on a Saturday, and I have a personal rule that I will not not answer a single text message from work on a Sunday. And I remember you texted me once on a Sunday. And I was like, what the hell are you doing in there? It is Sunday. Go home.
Yeah.
And, I remember talking to you on Monday, and I was like, let me ask you this question. Did any of it work yesterday? And you were like, no. And I'm like, well, there might be a reason why.
Yeah.
I
mean, sometimes it doesn't.
Yeah.
But a lot of times I did get that. So the benefit about weekend time is nobody's here.
It's quiet.
It's quiet, and I get
quiet.
to just think.
Yep.
So a lot of times it did work, but
No,
that one particular time.
No, I understand entirely.
Right?
It is a certain level of quiet that you just don't get during the week.
It's uninterrupted. You just come in, you do your work, and you leave.
Mm-hmm.
But no, it's during that time, and I mean, you definitely helped a lot with this too. But that balance of taking the time off is incredibly important because you just get lost in it.
I won't say that I was always like this when I was younger. Quite the opposite. When I first started in my scientific career, I was very much the exact same.
Yeah,
I was a ball of energy,
like just grind,
and it's like I need to grind as much as possible. And I mean, to a certain extent, yes, there is a reason for that, but also at the same time, no. You should absolutely not be doing
there's
that.
definitely a limit.
You absolutely do need to take a step back, and you need to blow off steam.
Yeah, absolutely.
I forget what weekend it was. I think it was around one of the holidays, whether it was Halloween or it was like Labor Day or Memorial Day. And I looked at you and I was just like, just take one weekend off. Mm-hmm. I'm begging you. Because you were so wound up. Mm-hmm. And I think this was right after you had gotten your rejection, and it was coming up on your second try. And I was like, just take a weekend for yourself and blow off steam. For the love of God, just do it. Yeah. Part of it was because I was tired of just seeing you. It's that empathic nature where it's just like, oh my God, he's freaking out again. Mm-hmm. Then there's the other aspect of it that's like, you're not doing any help to yourself at that point.
Of course not. Yeah, no, that makes sense.
When you're just sitting there so tightly wound, it's like you're going to make way more mistakes than you're going to have successes. So it was like, all you were doing was running gel. So it was like, is that your last gel? Yes. Go home and do not think about this place for the entire weekend.
Yeah.
And, I remember you came back on that Monday and you were like, you know what?
That was a good weekend.
That was a great weekend. And I came in and I was like, so how was your weekend? And you were like, it was fantastic. I didn't think about this place at all. Yeah. And I remember it was like one of the few weekends that your advisor was up in Vermont, so she couldn't even contact you. And it was like all the dominoes fell perfectly, and you finally unwound a little bit. And I think at that point you kind of understood what I was trying to get at by telling you got to take time for yourself, because again, it's mental attrition. It's an endurance race. Like, imagine if you had 3 more years to do everything that you still have to do. Imagine you had 3 more years to go for this. One of the things that I learned, I actually had a personal friend of mine who was a priest who was a lawyer before he became a priest, and I asked him what law school was like. He tossed me his letter opener and he said, jam that in your eye and then move it up and down slowly for every day, every minute of every hour for 3 years.
Jeez.
And I was like, what?
Why would you say that?
It's like, what? He's like, that is what it is like. Higher education kind of gets a bad rap for being like a vacation, but it is mentally a marathon.
It's hard work.
It is a mental marathon.
Yeah.
So the defense. What is it like? First of all, what is it like giving a public address, basically, of your work?
Yeah.
So let's start with that. Let's talk about the talk.
Right. So there's a lot of groundwork leading up to it. It's almost having gone through the defense, I almost think of it like a production. Right? Like leading up to it, I went into the room to look at how my slides looked and changed font. Like, it's sort of like that's what people are going to look at.
I taught you well, Kimasabi.
Right? So, and then prior to that, the rehearsal of practicing it, going through it. And then the day of, where you show up and you're in your suit, got your hair cut, and you're getting mic'd up and everything, and they're like, "Oh, this is the camera's gonna be, and there's gonna be a bunch of people on Zoom."
I could smell your anxiety, and I wasn't even in the same state.
No, yeah, I mean it is a nerve-wracking moment.
Yep.
At first there was a little bit of nerves, but I think I got rid of it pretty quickly. Like once I got in my groove, I was like, "Oh, I got this. Like I know exactly what I'm going to say."
Yep.
And so during the talk, I think it went really well. Honestly, I think that was just due to my preparation. I think it went really well. There are so many. Fortunately, there were so many people that came up afterwards. They're like, "Oh my God, you knocked that out of the park." One person was like, "Are you going to be a professor and teach? Because you should teach." I was like, "Yeah, no, I am very interested in teaching. I mean, that's one thing I would love to do." But through it all, the defense, honestly, I'm really glad it went well, and a lot of people had good things to say about it. And the experience was honestly incredible. It was great too, because it's sort of like a talk that you give, but that at the end, or you pretty much know that at the end of it, it's going to be a celebratory day. It's sort of like your moment of, hey, you did spend those days and weekends, and you worked really hard, and here is the culmination of it all. You get to give this talk that everybody listens to. Afterwards, a lot of the faculty had incredible questions. That I was able to answer, and they enjoyed my answers.
They hit you with some really good questions, and I was really happy with the way that you answered.
Yeah,
there are certain people that when they give the talk, they are solid on the talk.
Yeah,
and then the questions come,
they
and then the anxiety comes out.
Yeah,
and you didn't have that.
No,
you were
like, that's the thing. Once I got my intro out of the way, like slide 4, I was cool as a cucumber. I'm like, cool, I got this. Like I prepared for this so well that like I'm just gonna get through it and be done.
Hypothetical question for you now from the chat.
Okay.
You're approached by an eccentric billionaire who offers to fund your research for 3 years, but he wants you to come evaluate his dinosaur-filled island. Do you take the money?
So wait. I have to evaluate.
It's Jurassic Park.
Oh, yeah.
It's Jurassic Park.
Funny enough, to the first point of that question, we've talked about this.
Yeah.
We had this similar question of, hey, imagine you just had an unlimited supply of money. Like, what would you do? I think you were like, I would stroll into Penn and be like, give me a wing.
The funny part is, that was always the joke when I was coming up. It's like, if you had unlimited money, you'd bring in comically sized bags of money, like literally something out of a cartoon with the money
dollars,
symbol on it. And you'd just be like, this is so that you will give me a wing, this is so that you will leave me alone, and this is so that I don't have to hear you or see you come around my lab, period, for the next 3 years minimum. And, that was always the joke. But, we talked about this, I think it was like 3 weeks ago or something like that. It was right before I had COVID.
Yeah, we did. This is a recent conversation.
It was like, you asked me, you were like, if you had, unlimited money, would you do your research at home? And it's like, there are so many things involved in doing research that a lot of people don't realize. There's environmental issues, there's OSHA issues, there's a lot of rules that we actually have to live and abide by as scientists that a lot of people just aren't aware of.
Right.
There are what's weird is there are certain aspects of the Geneva Convention that we have to ascribe to and we have to actually follow because you have to make sure that you're properly informing people.
Yeah.
That's one of the aspects of HIPAA.
Right.
But HIPAA was informed based off of, previous experiences that people were having. A lot of people like to reference the Stanford prison experiment. One, that was a joke. And two, that wasn't something that actually occurred. That was, some people were actually, I don't want to say actors, but they were told how to act in certain regards to get certain responses out of people.
Really?
But, what was learned from that is that we can't just operate without reproach. We have to, as scientists, we have to conduct ourselves in a very specific manner.
Right.
And you know, one of the hardest parts is figuring out what comes next. And that kind of leads me to my next question.
Yeah.
What's next for you in terms of research?
Oh man, so that is a really good question. I'm not sure at this point, right? I think so. Once I get through the last year's medical school, at the point of residency, there are probably many opportunities that come in that I can jump on, projects that I can jump on. I have like a wide array of experience in different fields of research. I would be very interested in, honestly, anything that comes my way. Like, especially, I mean, if it is cancer related, that's always a plus. I feel like even if it was neuro related or gut bacteria related, like those kinds of things that I've done before, something that would interest me again.
Yeah.
So we'll have to see the next few years during residency. That might be when I get to delve into these different projects.
So now let's get into the actual reason why we're really here, which is to talk about the science. I mean, the show's called Science Talk, so let's talk about the damn science.
Let's do it.
So how do you feel cancer research has progressed in the last 10 years?
So cancer research, it's interesting, right? So I feel that the way in which the research has progressed, at least from my perspective, is that there's a lot of work, like the exciting work is, as you probably know, is mainly on immunotherapy.
Yeah.
So CAR T is a big thing, right? Bispecific antibodies are a big thing.
So if you could just explain what CAR Ts are.
Sure. So all these types of therapy are essentially harnessing your own immune system's ability to attack the cancer.
Yeah.
So intrinsically, our immune system does have that capability, but what cancer likes to do is it constantly is able to evade these things, right? So even like when a therapy is initiated, just a generic therapy, cancer can find ways to resist that therapy. And it's the same thing with our immune system. So our immune system can surveil for cancer cells, but cancer can sort of suppress the immune environment. It can stop the immune system from being able to properly tag that and get rid of it. And so the CAR T and the bispecific, those kinds of immunotherapies, it kind of more strongly activates the immune system to be able to target and attack cancer cells. So that's a very big form of therapy that's currently being explored right now. It has its benefits, right? I mean, for starters, in combination with that, what a lot of researchers are doing is they're trying to look for specific targets for that cancer. And what I mean by that is in our tissue, in our body, there are a variety of receptors or proteins that are expressed, right? And they have normal functions in our body. But in cancer, there are certain receptors or proteins that get specifically upregulated that allow for that cancer to continuously grow and divide in an uncontrolled manner. And so those receptors are currently being explored. Like one of the more popular ones now is EGFR.
Yep.
It's a growth factor receptor. It's actually, I think that treatment's already been approved for some cancers. Small molecule inhibitors that can inhibit that receptor and inhibit the growth of cancer. And that type of therapy can be effective because the cancer can highly express that receptor while your normal tissue may not have as much of it. And so that's sort of the million, or maybe I should say $1 trillion question in cancer is, how do we kill just the cancer while keeping our normal tissue unharmed, right? That's like the big thing right now that is, in especially aggressive chemotherapy, can be an issue.
Yeah,
right.
Because isn't chemotherapy in a word basically just bombarding your system with the maximum amount of toxicity that you can survive?
Yeah, potentially, right? So when you get to the aggressive stage 4 type cancers and you have to go through aggressive chemotherapy, one of the things that happens is those drugs will kill cancer, but it will also kill regular tissue that's also perhaps rapidly dividing, right? Your epithelium, the type of cells that are in your gut, that make up some part of your skin, your hair, these things get attacked as well, and that's why you see a lot of those very harsh side effects that come with it. And so with this immunotherapy in combination with trying to find those markers that are unique to cancer, and by unique I mean it's not purely unique, right? There will always be some level of off-target, at least for the time being. There can be some off-target effects, but somewhat unique to the cancer where this receptor or protein is significantly upregulated in this cancer, but it's minimally present in normal tissues. So when we use this drug that targets that, it can target the cancer while minimally harming. It might to some extent harm, but if you find the right dosage, maybe you can minimally harm your normal tissues. So that's kind of where it's going.
Recently, there was a article that I saw, pardon me, that said that they posed a question to AI about cancer. I forget if it was a specific type of cancer. It was probably something like liver cancer, because that's always the cancer right now that's really big. And they found that it would cure it as we would term it, and they even had it predict minimal side effects. How much do you trust that kind of result?
So I'd have to read into that specific article you're mentioning.
Good answer. I have taught you well, Kimasabi. You have learned from me very well.
Right. But at this stage, right, when we talk about curing cancer, it's very hard to come to that conclusion because, as I mentioned, with a lot of therapies, cancer has this uncanny ability to mutate and to have different resistance mechanisms to the therapies that we're initiating. And so really, I think for cure to be the term that we use for therapies, there has to be a long-term follow-up, in my opinion, right? Like, you have to see whether this actually does completely eradicate. Because, one of the other big issues, even with, so let's take, like, surgery, for example, right? If you remove a tumor, one of the big issues even with that is that's not even itself curative, because even the smallest amount of residual cancer cells left can just do its thing.
Right.
And so, that kind of concept makes it very difficult to say that a drug or something is potentially curative to the cancer, because that's really the hardest thing that we're facing right now. Is it's so hard to cure cancer because of its ability to evade the immune system, its ability to sometimes the cancer, that even a couple of cells can then develop again into a tumor. So it's very hard at this stage right now in our development of research to say that something can be curative, right? I feel like a long-term follow-up to that would have to be initiated to really make sure that this is the answer.
Yeah. So cancer recently, we're starting to see more targeting. Like
Yes.
Whenever we see cancer treatment being talked about in movies and TV and comic books or anything like that, we're always talking about, well, first of all, it always talks about chemotherapy like it's radiation.
Yeah, those are two different things.
Radiation therapy and chemotherapy are two completely different things. In fact, nowadays you can even get chemotherapy via a pill.
Yes, most
rather
of them,
than just getting a port installed and then having it drained in that way.
Some of them can be in pills,
But we're starting to see targeted levels of chemotherapy where it's only going to be in one portion. I think there's one research group that's right now utilizing a neural network to actually map out the specific area that it's going to sit in, all, for lack of a better word, live in, to attack the cancer, and it's going to go nowhere else. And affect no other tissue.
Interesting.
I mean, whenever we talk about chemotherapy, especially because my mother went through breast cancer breast cancer therapy, and she had to go through both chemotherapy and radiation therapy. And I'm looking at her and I'm like, chemotherapy is going to cause you to hate your teeth. It's going to cause you to lose all taste buds. It's going, basically anything that is rapidly developing tissue is going to be affected. So you're going to have issues breathing. So that means you're taking your asthma medicine every day. You better be getting that inhaler in like clockwork. And to a certain extent, I was trying to do my best to prepare her, but quite honestly, again, it was also my mother,
Right.
but there's almost nothing that you can say or do to properly prepare that patient
Oh,
for
yeah.
what's coming.
Yeah, that's so true.
You know,
It's a difficult,
yeah,
and I haven't had, so one of the specialties I may go into is hematology oncology. You know, that's one of the things I'm getting prepared for is those conversations.
so that's for
Difficult.
like specific to leukemia and things like that.
Yeah. Well, the oncology part's more broad.
Right.
The heme part would be more
Yeah.
blood disorders and cancers, but that's the specialty where you're going to have those difficult conversations with, you know, potential future patients on, hey, we're going to try. So like you said, a lot of targeted outside of chemotherapy, like those EGFR inhibitors, et cetera, they're coming to light. Some are being targeted through CAR T and the immunotherapies that we discussed. And there's probably even newer things out there that are coming out constantly every day, you know, and we can, based on now cancer is starting to, you know, when you biopsy tumors and whatnot, you're starting to be able to get to a point where you can say, hey, this therapy may actually work for you, or this is not the best route. And so when you get to that point in the clinical terms, like it's going to be very sometimes difficult to have that conversation with patients where maybe there aren't any viable options at this point, but we just have to try something, you know, and it's,
so
I'm sure that's a tough conversation.
So we have one of the best examples of what it is like to go through cancer in the United States in the form of the TV show Breaking Bad. And obviously there's some narrative license that's taken with the disease. But one of the first things, I don't know if you watched the TV show at all, but one of the first things that his wife has him doing is doing all these homeopathic methodologies.
Really?
And
Okay.
all it seems is that it's making him worse.
Okay.
What it seems like it's doing is, because he's coughing a lot and he's actually bringing something up, it actually seems like the homeopathic remedy is actually causing him to shed more of the epithelial layer inside the lung tissue a lot faster, which is causing him to have to bring it up. How do you, in the cancer world, treat these homeopathic methods? I mean, are they just snake oil, or is there something to some of them?
Yeah, so, you know, I don't know too much about homeopathic methods, to be honest with you. I feel like in the cancer world, it's usually not the first line method, you know, that clinicians will go to. But I'm not sure in the clinical world if it's actively discouraged or not.
Yeah.
I would think maybe it is, because, again, with the homeopathic methods, there may not be a lot of evidence-based medicine behind it to support them.
Yeah.
Right? The research, anyway, to back the fact that these things may or may not work, you know. There's definitely benefits to certain things, I'm sure, like drinking certain teas with antioxidants, like things like that can help prevent certain things from happening.
Well, I mean, at that point,
but it's
you're
not necessarily
talking about
treatment.
You're talking about,
you know?
like, attacking specific aspects of the cell cycle. I mean, you're talking about an antioxidant is going after like the reactive oxygen species.
and that's more. And my understanding of antioxidants is it's usually a preventative measure rather than an active treatment, right?
Yeah.
Antioxidants are good for a lot of things, not just necessarily, I guess, cancer, but many things, right? And so, like, those kinds of things, like drinking herbal teas, things like that, can be very healthy for you. But in terms of treatment of cancer, I think the sort of the traditional Western medicine, so to speak, is the gold standard for what a lot of clinicians go for with treatment.
So it's interesting that you explained that. Now, you had mentioned earlier that you were born in India, and I'm assuming for a short period of your life you were raised in India. I don't know how old were you when you actually came over.
So I was almost 5 years old. I think I was like 4 years old when I came to the States.
So, you know, one of the things that I've been noticing, especially because of southeastern China, they have actually been maintaining I want to say that they've been maintaining a true almost lineage, but they've been maintaining a certain level of their traditional Chinese medicine for years, which is very much humors and qi lines and all that. But, you know, the Indian subcontinent is a huge melting pot of different cultures, different religions. I mean, I think there's like 4 different religions just inside India. I think it's, you've got Hinduism, you've got Catholicism, you've got Islam, and you have Sikhism as well.
I think Jainism might still be
Yeah,
around.
I think Jainism is still there, and I think there's even like offshoots of Hinduism now in there. And there's probably tons of associated homeopathic remedies in there. What is the value as doctors, as clinicians, as researchers to potentially bring these things into it?
I do think that those methods, if we research and dig into it, they can be viable options, right? Like actually, I don't know if a lot of people know this, but some of the chemotherapies that we use in today's world, like let's say paclitaxel, is actually derived from a tree. It comes from a tree. And there's so many other varieties of chemotherapeutic agents that actually come from plants. Right. And it's their specific compounds that we've extracted from it.
I always love the people that are like, I'm getting away from chemicals. I'm just getting away from all these chemicals.
Yeah. And you're like,
the poor chemists are sitting there like, everything is
everything
chemicals,
is a
man.
chemical. Yeah. Like these chemotherapy drugs are originally derived from trees and plants. And so I think there is utility in my research actually explored that too. We used naturally derived compounds as anti-cancer agents. And so I think there is utility in looking into these naturally derived sources for treatment for certain things, but my biggest thing is there has to be enough of a research backing for it, right? Yeah. Like the sort of anecdotal stuff is not strong enough to pursue it. But I do think a lot of those, like for example, there are probably many it's Ayurvedic medicine and traditional Indian medicine that probably has a lot of utility, and I think it's worth exploring.
I believe one of them, because it's interesting that you mentioned that. I think one of them involves chewing a root and then pulling it out of your mouth and actually sticking it into the mouth of the patient. And the reason why is, if I remember I don't remember the exact treatment, but if my memory serves, and it's not as good as it used to be. But if memory serves, they put it in their mouth because human saliva breaks open the cells to allow the chemical to be accessed. And the person that is being treated can't do that. And, we treat, like, this person's chewing on a root and then they're putting it into somebody's wound. We treat that as like backwards medicine. When in actuality, that's like, there are plant leaves that if you mash them up and then stick them in your wound, they're an analgesic. And it's like, they're pain relievers.
Yeah, like a lot of the stuff that we get, right? And so, no, I think there is utility in investigating that, but I do believe in order for those to be viable treatments for, let's say, cancer, we have to know, not exactly, but we need to know how it works. Yeah. Right? From a scientific level. Like the stuff that we talk about and do, we need to figure out its mechanism. We need to figure out if it's doing anything treatment or curative-wise in vitro, if it's happening in vivo. If it's how it's faring in clinical trials. Like, I think it needs to go through a rigorous scientific
you have to beat the scientific burden of truth.
Yeah, both bench and clinical in order for those kinds of natural therapies to be viable and possible treatments.
Yeah. We're getting to 6 o'clock and, both you and I have been here since a very early point. I don't want to keep you all night. So while we're letting our audience come up with some of their final questions and final thoughts, I just want to say thank you so much.
Oh, of course.
Because, we've been doing this a lot, and I know you attended one of them, and you enjoyed it, but number one, you finished your requirement. You could have been just worrying about your rotations at this point. Right. But I do appreciate you coming on, taking the time to enjoy it. I hope you got some enjoyment out of it. But is there any questions that you have for me that you've been wanting to ask me? Because you kind of had unlimited access to me for the last 10 months. Yeah. Is there something that you've always wanted to ask that you maybe didn't get the chance to?
Honestly, no. I think we had some great conversations, during our time since I moved over here and did my research here. I do want to say I really appreciate you inviting me onto this.
Not a problem.
And to Joe's followers as well. This has been honestly incredible just to sit back and forth and talk about these things. And
Yeah, it's interesting.
I think, as you mentioned too, I'm also really big on this, but just exposing anybody and everybody to science and to medicine.
Yeah.
Getting that information disseminated in the appropriate way. I think it's very important, that we as a scientific community do better at disseminating and accurately getting this information out to people in a way that they're not only happy to engage with, but like they can do it in a way that they can understand.
Yeah.
So no, this has been incredible. I'm happy to be here.
Oh, great.
Yeah.
So there is a question,
Awesome.
and we have a historical example of this.
Okay.
But I want your opinion on it before I give the historical example.
Sure.
So has any of your research come to the point where it's being used on people, and how true is the stereotype of the Hail Mary experimental treatment?
Yes. So my research in particular, no, it's nowhere near.
It's too new.
Yeah, so my stuff has all been done in cell culture plates, right? We've investigated these in cells that we grow, and so that's in the very beginning, very, very early stages, right? There is and a lot of times, people can do this stuff in cells and then find out that perhaps it's not very efficacious in an animal model. I'm not saying that's the case with our work, but we have to go to the next step, in order for this to even have the possibility of thinking, oh, we can do this in humans, right? So my work is very much not there yet. It's in very much the beginning stages of that. But yeah, in my experience, I have not had any sort of Hail Mary scientific experiment like the eureka moment, so to speak. I mean, I've had those.
Eureka moments.
I've had eureka moments, but not the way they show on TV, where it's like a big breakthrough and you did it, you cured the thing, you did the thing. You know what I mean?
A lot of times it's like, oh my God, I figured out that piece of the puzzle that I've been looking at for like 6 years, and it doesn't really advance it that much. But
and
it's
if
really
you talk to somebody normal, they'd be like, who cares?
Yes.
And you're like, no, I care.
Yes.
This is a huge deal. Like,
so
So that's what I would say to that.
To provide the historical example of the Hail Mary experimental treatment, we have to go back to 1984 with Sam Wang. Dr. Sam Wang. You know this because it's H. pylori.
Mm-hmm. Yeah.
We knew for years he knew for years due to experimentation that H. pylori, which is a bacterium, causes ulcers. And the wider medical community just kept saying, you're a crackpot,
yes,
you're silly, you've never been able to repeat this in an animal experiment. Why do you keep doing this? It's stupid. Mm-hmm. So he basically went back to his lab, and grabbed broth, which, by the way, it was LB broth, which is Lueraria broth, which is disgusting. Yeah. If you ever get it on your tongue, it's awful. I've had the unfortunate pleasure of tasting it,
really?
And it's bad. It smells like past expired chicken soup. That's what it smells like. And what he ended up doing was he drank the broth with the organism in it, waited a few weeks for the H. pylori to cause him to have an ulcer, got an endoscopy done, and then he treated it with antibacterials and proper treatment, and literally done. And then he had his moment where he just was like, deuces, took a crap on the desk and just flipped everyone off in the room and was like, I knew this the whole time and you didn't.
Yeah. I feel like in the modern era,
he would have lost his medical license. He would have been barred from
much. There'd also been like N=1, do it again.
Oh God! Oh,
am I right?
Yeah, no, he's right. No, yeah, that's true. There's going to be some guy.
We need a repeat.
There's always that one guy that's like, even if you repeated this 100 times, it's like, I want you to try it one more time. Just look at that guy and you're like, I hate you. God. Do you understand how much this experiment cost? So yeah, I mean, that's the real world example. Yeah. So, some final thoughts. I want to thank you so much for coming on. Yeah. It really does mean a lot to me. Again, this is the period of time that you kind of get to take off before going back to your medical work. But I really appreciate you coming on, and I know our audience also appreciates you coming on. And in the future, I want to invite you back because in your journey, you're going to get many different more experiences, more ideas. And I'd be more than remiss to not invite you back to discuss those things, especially if when your paper comes out. Contact me. We'll do a virtual version of this, and we'll talk about your paper. We can talk about your research and see how it how it can benefit people. So, again, thank you so much. And like I offer with every single guest on here, you have the floor to talk about whatever's going on in your life or whatever you feel the need to talk about right now. Go right ahead.
Oh, right now?
It's all you, man.
Oh, no. I honestly just wanted to say thank you for having me here.
My
because
pleasure.
This is I can't believe has 2 hours already gone by. This
is it's 6:07.
Yeah, time is flying by the way during this conversation.
Now you understand why I say sometimes we're here until almost 7 o'clock because we're just not paying attention to the clock.
No, this has been incredible. So I really appreciate you having me on, and I appreciate everyone who's watching and listening. Thanks so much for being here with us. Those questions. We had so many incredible questions today.
No, it was great.
I think that was a really cool, fruitful discussion, right?
No, it's good.
So no, that's pretty much all I have to say. Really appreciate you having me on, and
awesome.
I'm happy to be here.
Awesome. Yeah. Let me take us home, and then we will all be able to have some dinner, some well-earned dinner. I want to thank you all for joining us tonight. I hope you guys had fun. I know we did. If you enjoy content like this, please give us a follow. Join our Discord. If you're watching this on YouTube, make sure you like, follow, and subscribe because that makes YouTube very happy. Again, as I always say, you don't have to subscribe because I do this for fun. I do this in my spare time. And also a final thank you to Vig as well as all of our other guests because, again, as I always say, I do this at the end of the workday. So this is technically on everyone's personal time. And I really want to thank everybody for taking that initiative to be on here for that personal time. And, as always, if you feel the need to subscribe, I really do appreciate it. It helps me kind of keep doing all of this. Thank you guys so much. As always, the links are going to be in the description below and on my Twitch homepage. So long, everybody. Thanks for all the fish. Bye-bye now.